I've reviewed and taken apart some different dancing flame candles in the past, and this is one I just got a few days ago. And it seems to be the evolution of these things. It's a cheap one, but at £8 it's about a quarter of the price of the original Luminara. But it seems to be going in the right direction. It is a real contender for the Luminara candle. It's got some features that actually make it quite special. The first thing I noticed about it, it takes 3 AAAs, and to be honest, I'm not a fan of AAAs. I prefer beefier AA type batteries just because they have 3 times capacity. But now, having actually just experimentally tacked some leads on the meter and tested this, notice there's a big divot out the wax here. I think that's happened during the manufacturing process. It's not me because I've not had it open yet. That will happen, that it will probably be destroyed shortly, but hey, all in the name of science. I have applied power from my bench meter onto this, not bench meter, a bench power supply. And a really interesting and good feature is the fact that the LED isn't going through a boost converter like the other ones. It's not being stepped up to about 3.3 volts from 2 cells, because that was a major weakness in the other ones. Both the Luminara and the Premier Dancing Flame, when the battery just starts getting anywhere near the end of its life, the LEDs will start pulsing on and off quite violently, because the current draw of the coil that deflects the flame is actually having a significant effect on the voltage, and it makes the LED fluctuate quite significantly. It also means that as the voltage goes down, it just tries boosting it up, and it shortens the battery life. This one, on the other hand, when you turn the voltage down, the LED just gradually gets dimmer. It's very clearly, well, probably just a resistor from the battery supply. And down below about 3 volts, it goes down to about 2.6 volts before the LED's just barely glowing. And at that point, it's still reflecting the flame. So I think the batteries will last a long time, because as the voltage goes down, the current drops significantly as well. And the current doesn't even start off too high. So I think that these are going to last a good length of time, just getting a wee bit dimmer as they go. And instead of being the situation that you have to change the battery when the thing starts strobing and flashing, it'll be more a case of when it gets dimmer that you think, time to put new batteries in, it's a bit dim now. On the subject of batteries, it does say in the back, do not use rechargeable batteries. I'm not sure why, because with the modern nickel metal hydrides, I would have thought they'd be ideal for something like this. But then again, I'm not sure why they say that. It certainly works fine in 3.6 volts. I've tried it. So let's take the batteries out and see if I can open this non-destructively. It appears to be the same plastic housing. In fact, I'm quite suspicious it may actually be from the same factory as the Premier Dancing Flame candle. And the body is solid wax, and in the past I've broken quite a few of these trying to open them. However, I discovered in the past that if you put a tube down on that, and this is where I should have looked a tube out beforehand to try this, but you can actually push it and it slides the whole assembly out, and it's a sort of goopy, chewy glue fused onto the wax. I'm just going to grab a tube now. I'm just trying to think what I can use. Solar Garden light tube? Is this going to be too... Oh, this is about the right size. Oh, this is going to be... This is where it either bursts or comes out. Actually, that's sliding out quite easily, and it's out. Okay, it's very oh, I see a big difference. I see a big difference already, and the circuitry, instead of having a circuit board down here, and just the coil up here, everything is on the one circuit board now, except the LED is still sandwiched in. It is very much the Dancing Flame housing and the way of mounting the LED and presumably the flame. Okay, let's open it up. The colour of the LED is also very good, because the Premier Dancing Flame one had a strange ghastly white. It wasn't cold white and it wasn't warm white, it was just not candle white. This one is closer. It's very much a step in the right direction. So it's going to come apart in a... Oh, this is glued actually, but that's alright. Ooh, right, okay, that's how that comes off. They probably do this in different heights, like they did with the Premier version, where they just stick a different bit of tube in for different candles. So let's see if this comes apart now. It's been kind of trapped together with that glue at the bottom. Okay, right, the LED is just sandwiched in. The flame, with its little magnet in the bottom, is exactly the same as the Premier Dancing Flame. It's that little, it's almost like a staple with a slight dimple in it. And it just sits into two holes, and it's got a slight dip in the middle, well not, but a wee bit further back from the middle, that stops it, that kind of keeps the flame centred. The circuit board has a little 8-pin chip in it, which just immediately says PIC 12 with a 4 megahertz crystal and the two little capacitors with that. Is there a number on the chip? Let's try the magnifying glass, and then we'll try the magnifying glass doesn't reveal. Although having said that, if this is anything like some of the others, there may not be a number on it. Is this one of these little anonymous pick-a-likes? I think it is. It's got the same pinout as a PIC microcontroller. Microscope. Bigger coil. I guess it's just driving the coil directly from the PIC. No, that chip is very much one of the anonymous little 8-pin chips that looks suspiciously like a PIC microcontroller. A PIC 12. Okay. I wonder if they are PIC 12s, just supplied anonymously from Arizona Microchip, or if they're just a complete rip-off. I'm guessing a complete rip-off. So the coil, oh look, there's extra pads at the back here for an infrared sensor for the remote control. So they've tried implementing the infrared remote control again. But, well, they've left the facility for it, as they did in the previous one. The coil, does it have anything? Is it connected directly to a PIC? It's through a resistor to the PIC microcontroller. Really, there's not really much else to it. Really, that's fundamentally it. There's a resistor going from the microcontroller to the LED, so the LED is being switched through the chip. And that's probably for the timer function. It has the time facility that you can either switch it on, or you can switch it to timer mode. And in timer mode, it comes on for about 6 hours and then goes off for 18 and then repeats. So, you know, if you turn it on at 6 in the evening, it will stay lit till midnight, then it will go out and it will come on at 6 the following evening. That's probably why they're using the crystal for the timing aspect, because as the voltage goes down in PICs, their frequency drifts. The switch at the bottom it's a 2-pole, 2-way switch, with the sender is off, and whichever way you switch it, it's got the negative linked. So the only difference is that if you switch it on, it just provides negative to the actual circuitry and runs it. But if you switch it the other way, it turns the circuitry on, but it also pulls this white wire low, so that's probably pulled high internally in the chip. Yeah, it's going straight to the chip, I think. And that's how it will detect it's in timer mode. So, this is the evolution. I have to say, a couple of things strike me about this one. It's a bit smaller. That must just be to save money, I suppose, really. It's using the same circuitry and arrangement, but it's being much gentler with the coil. It's not battering the flame about like the other one. And the flame does keep wobbling about right down below the point the LED has gone out. So it's got a very wide voltage range. It's going to last a long time on those batteries. It's going to gradually get dimmer. It's not going to hold constant brightness. But having said that, it's no great deal. It will just gradually get dimmer as the batteries run down, and that's it. The flame movement is very good. I've not actually tested what it's actually doing to the... you know what? I'm going to test that right now by sticking an LED across that coil. Is that going to work, or is it not going to work? I'm not 100% sure. Let's try it. The previous design just pulsed at a series of on pulses, and then it would be leave a wee break, and it was just a regular pulsing of the coil. It wasn't some sort of randomizer, and I can understand why they're doing that. Because if they're trying to derive accurate timing for the on-off cycle, then they want to avoid any sort of random, excessive processing that's going to interfere with that. They probably want to use the same sort of timing delays. So let's find an LED and stick it across that. A red LED would probably be a good idea. Do I have a red LED handy? Yes, I do. Because the coil will probably pull the voltage down. It might not even be enough to actually light this LED. So it's... I think it's going to be this polarity. Oh, you know what? I think the coil is probably pulling the voltage down that too much to actually light the LED. So the only way I can actually test that then is to try and get on the other side of the resistor for that, and try not to break it in the process. So let's choose a suitable value, 220 ohms. So I think we'll just touch that to negative. I'm definitely going to break it, I'm going to short something out. It's inevitable. And I'll stick that on there and probe. Oh, well, I did see a brief flashing. I think I've just slipped the connections though. Oh, definitely slipping with that connection. If I get anything better I can do this that I can probe with? Not really. I'll take that out completely and just put this in the end. Sorry, this is taking ages. It's just because I've been distracted, haven't I, really? So let's, I may have crashed the processor, I don't know, I doubt it. Maybe I have actually, by footering about. Not 100% sure, I don't see it pulsing the coil unless I have actually knackered it. Let's try turning it off and on again. Oh, actually, you know what? My fingers are actually messing with the circuitry there. Okay, let's try again. Oh, this is all turning a very long-winded one. I might just actually tag this onto the negative over there, it's easier. Yeah, you know what? It's just doing exactly the same as before, just routine pulsing. Oh, it does seem to be doing... No, it's just a series of continuous pulses and then a wee gap usually. Yeah, it's just doing what it did before. Well, that took a while to find out, but yeah. So, all in all, it's a step in the right direction. It's better than the previous version because it is just that little bit gentler, and because it's running the LED directly from the battery supply. So yeah, you know what, this is the best of the cheaper ones yet. It really is a good contender visually for the Luminara.